This video is going to focus on the slope formula, which we see in front of us right here. M equals y2 minus y1 over x2 minus x1. M is the letter that mathematicians use to designate slope. I do not know why they use M instead of S, but this is what they use. y2 minus y1 represents the change in the y values between your two coordinates that you are using to calculate your line slope. Similarly, x2 minus x1 are your two x values from your coordinates that you are using to create your line. So, if we were to have, let's say, 5, 3 as one coordinate, and 7, 1 as the second coordinate, I could label these as x1, y1, and x2, y2. That would allow me to use this formula by simply substituting in the y2 for 1, the y1 for 3, and subtracting, and doing the same thing with our x values. That's pretty much all there is to the slope formula. You have 2 points. You're trying to figure out the slope of the line that connects these 2 points. And this is the formula that does that for us. So let's try a couple examples. Let's say we have 2 points, one being 3, 7, and the other being 4, -2. There is a line connecting these 2 points. So, you know what? Let's draw it real quick. I've got 3 and 7. So a point here, and then I have 4, -2 down there, and there is a line connecting these 2 points. We want to know the slope of this line. How fast or slow is it changing over time? So we use our slope formula here. Now, as you saw me do previously before this example, I always think it is a good idea as we are beginning with our slope formula to label our points as x1, y1, and x2, y2. That helps us keep ourselves organized and use the formula effectively. So I'm going to say this is x1, y1. This is x2, y2. And now I just have to put it into this formula. y2 is -2. So I have -2 minus y1, which is 7. So minus 7 over x2, which is 4, minus x1, x1, which is 3. So, by taking -2 minus 7, I get -9. 4 minus 3, I get 1. And my slope here is -9 over 1. Some of you might be saying, hey, you can simplify this down to just -9, and you are correct. Now, this is going to vary depending on your math teacher, but I prefer my students to leave their slopes as a fraction as opposed to a whole number. If it's a whole number, always put it over 1. The reason for this is when we start to graph based off of our slope, a fraction is going to do us a lot more good than a whole number will. And we definitely do not want to use decimals. We want to use fractions. All right, so that's using the slope formula. Let's try one more and then move on to another topic. All right, for our second example here, we have the points -5, 2 shown right down here, 4, 9 shown right up here, and I've drawn the line that connects these 2 points, and we're trying to find out how is this line changing from left to right. What is the slope of this line? Just like we did in the previous example, I recommend starting by labeling your coordinates. x1, y1, x2, y2. Now we can plug them into our formula just like before. y2 is 9, y1 is 2. So our top is 9 minus 2. x2 is 4, x1 is negative 5. So our bottom is 4 minus a negative 5. When we simplify this and work it out, we get 9 minus 2, which is 7. And we get 4 minus a negative 5, which is the same thing as 4 plus 5, which gives us 9. And this time we have a slope that is 7/9. We cannot simplify that. We do not want to turn it into a decimal, so we leave it as simply 7/9. And what that tells us is, as this line moves from left to right, it's going to go up 7 and over 9. Alright, now this has been fairly simple as long as we are given 2 points. As long as we have 2 points, we are going to be able to create our slope. But what if we are given an equation as opposed to 2 points? Let's see what we would do in one of these situations. Here we have the standard linear equation form of 6x minus 5y equals 30. I want to figure out the slope of this line. Well, to figure out slope, I need 2 points, and currently all I have is an equation. Well, here is where a topic from a previous video will really come in handy. I may not have 2 points on this line currently, but if I remember about intercepts, I can very easily get 2 points from here. So I'm going to use my cover-up method. I'm going to use my cover-up method to get my x and my y intercepts, and from there I'll be able to use my slope formula. So let's pretend that this 6x is not here. I'm going to move it away for the time being. And what do we have? We have negative 5y equals 30. If I were to solve this for y, divide by negative 5, I would get y equals negative 6. So that tells me my y-intercept is 0, negative 6. Alright, now if I were to get rid of the negative 5y and bring back my 6x, now I can get my x-intercept. So I have 6x equals 30. Solve for x, divide by 6, and I have x equals 5, meaning my x-intercept is 5, 0. Now, all I have to do is use my slope formula that we used in the previous sections. So our slope formula is m equals y2 minus y1 over x2 minus x1. And we can get rid of this in the middle because we don't need it anymore. And we have our 2 points, 0, negative 6 and 5, 0. Label our points, x1, y1, x2, y2, and start finding your slope. y2 is 0, y1 is negative 6, so 0 minus a negative 6, over x2 is 5 minus 0. 0 minus a negative 6 is the same thing as adding a 6. So our slope becomes 6 over 5. And if we look at our original 6x plus 5y equals 30, we might be tempted to say, hey, look, 6 and 5, they're right here. That's going to become our slope every single time. I found a shortcut. No, you did not. sorry to burst your bubble, but that was a coincidence with this situation. It is not always going to work out that way, unfortunately. So do not get in the habit of thinking, oh, I found this wonderful shortcut and it's going to work out perfectly fine every single time. It will not. Okay, let's try one more and we can see that this possible shortcut you thought of will not always be true. Okay. Here we have 6x minus 4y equals 12, and we want to get the slope of our line. Just like we did in the previous example, we need to get our x and y intercepts first. So I'm going to do like I did before and pretend this 6x is not here. And now I have negative 4y equals 12. If I solve for y by dividing everything by a negative 4, I'm going to come up with y equals negative 3. So my y-intercept is 0, negative 3. Alright, now if I were to take and get rid of the 4y and just keep the equals 12, I'll throw that on my 6x there. If I want to solve for x, I need to divide by 6. That's going to give me x equals 2. And my x-intercept will be 2, 0. Okay, now I have my 2 points, so I can solve for my slope. Hopefully by this point you have your slope formula memorized, but in case we need to hear it one more time, m equals y2 minus y1 over x2 minus x1, where x1 is 0, y1 is negative 3, x2 is 2, x2 is 2, and y2 is 0. Okay, and we plug our numbers into the formula. So I have 0 minus a negative 3 all over 2 minus 0, which ends up giving us 3 over 2. So our slope is 3 over 2. Our original problem, remember, was 6x minus 4y equals 12. So we cannot say that just taking our coefficients is always going to give us the slope. You notice I have 6 and I have 4 here. My slope ended up being 3 and 2. So do not get in the habit of thinking that this is going to always give you your slope as a shortcut. You need to find your points, use your slope formula, and calculate out your slope. There we go. Hope you found this video useful, and good luck calculating the slope of a line between 2 points.